example, we have a disk of mass m and radius r. We had a disk of mass m, radius r. From this disk, this portion has been cut, where its radius is r by 2. This portion has been cut, and we are supposed to find the moment of inertia of this remaining portion about this axis. That is I z z dash about this axis, a or a dash, that is what so you say, that is I z z dash passing through a. Right? This is the moment of inertia we have to find of this remaining portion about this axis. So the basic concept which we use over here is, let's say there are two particles, 2 or 3 particles. One is m1 at a distance r1. The other is, let's say, m2 at a distance r2. So we know moment of inertia of these two particles about this axis I y dash is going to be m1 r1 square plus m2 into r2 square. Simple. Now if this particle is not here, either we can directly say the moment of inertia of this is m1 r1 square, or we can say, because now m2 particle is not there, so its contribution towards earlier moment of inertia, it has to be deducted. That is, whatsoever had been moment of inertia minus m2 r2 square, that had to be deducted. So this get cancelled, so it comes out to m1 into r1 square. Perfectly right. Same concept we shall be using when we find the moment of inertia of this remaining portion about this axis. So how we intend to proceed is, first we find the moment of inertia of this whole disk. Let's say that had it been whole, we find the moment of inertia of this complete disk of mass m, radius r about this axis. How we find the moment of inertia of this whole disk about this axis? That is, we can use parallax theorem. About this we know mr square by 2 plus these two axes. That is, these two axes, they are parallel to each other. We know about mr square by 2 plus m into x square. What is x? X is r. So we can find the moment of inertia of this whole disk of mass m and radius r about this axis. Then we subtract the moment of inertia of this portion which has been cut of this portion about this axis. For that, what we do is, if we have to find the moment of inertia of this cut portion about this axis, we find the moment of inertia of this portion about this axis, and then about this we can use, once again using a parallax theorem, we can find this distance, and through parallax theorem we can find the moment of inertia of this disk also. Then from the earlier, that is moment of inertia of the whole disk about this axis, we subtract the moment of inertia of this disk about the same axis. It is not midway, we cannot change the axis. It is not moment of inertia of this body about one axis minus moment of inertia of the other body about the other axis. We cannot subtract or add these two moment of inertia. Moment of inertia is always of a body about an axis. So we are finding the moment of inertia of this remaining portion about this axis. Now for that, what we say is, that is, number one, if this mass is cut, so obviously this is not, if the whole mass of this whole disk has been m, so the mass of this disk is obviously going to be smaller. When area is pi r square, the mass is m. When it is 1 unit, it is mass per unit area. Now its radius is r by 2, so area is pi r by 2, its whole square. So its mass is going to be m upon area into area, that is pi r square by 4, so it comes out to be m by 4. So mass of this comes out to be m by 4 units. Now we say I of the remaining portion, zz dash axis passing through a about this is what? That is I of the whole disk about this axis minus I of this disk about this axis. I of disk, whole disk about this axis is mr square by 2 plus mr square. That is, we have used parallax theorem, and it comes out to be 3 by 2 mr square. Simple. Now we come out to, now we find the moment of inertia of this cut portion. Now we know that is moment of inertia of this cut portion. How it can be calculated is, we know that is moment of inertia of this portion about this axis is, what is that? It is m r square by 2. That is, the pattern will remain same. Whereas now m stands for the mass of this disk, which is m by 4. R stands for radius of this disk, which is r by 2. So pattern remains mass into radius square upon 2. That is m by 4 r by 2 square by 2 plus, that is parallax theorem, m into x square, mass of this into distance this am. If we draw this triangle, that is a is here, m is here, o is here, so this we have to find out. So this is r, from here to here is r, from here to here is r by 2. We can find this using Pythagoras theorem, which comes out to be, that is am square is equal to r square plus r by 2 square is equal to 5 by 4 r square. So moment of inertia of this cut portion comes out to be, that is this plus m into x square, the distance between the two, am. AM had been 5 by 4 r square. So this comes out to 11 by 32 mr square. So now we know the moment of inertia of the whole disk about this axis, and we also know the moment of inertia of this cut portion about this axis also. And in both the cases we use parallax theorem. There could be cases where we have to use the perpendicular theorem also. It depends from case to case. It may be the cases where we have to use the parallax theorem also. We may have to use the perpendicular theorem also. So in this case, it is just by using the parallax theorem we can get the moment of inertia. So it is I remaining portion is equal to, that is of the whole disk about this axis 3 by 2 mr square minus moment of inertia of this disk about this axis, that comes out to 11 by 32 mr square, that comes out to be 37 by 32 mr square. So if from a body some portion has been cut, so one way to proceed is find the moment of inertia of the whole body about the axis, then subtract from this the moment of inertia of the cut portion about the same axis, and you will find the moment of inertia of the remaining portion about the asked axis.